IGCSE past papers. We have May, June 2020, paper 21. This is number 19. So we have a cuboid here. The length of our cuboid is 20 centimeters. The width is 5.5 centimeters, but the height is not given. The volume of cuboid is 495 cubic centimeters. Find the angle between the line AG, this one is our line AG, here to there, and the base. This one is the base. So we are going to find this one, the angle here. So we need first to find this AG, we have this triangle. Okay, so if we are going to draw that one, so we have this one. Okay, so this is point A, and the G is here. From this corner to the other corner, from the lower corner here to the upper corner on the opposite side here, not here, there. So this one is a corner, upper corner, lower corner, and we have this one here is the C, this C. So we have a triangle there. This one is 90 degrees. This one, our AC is actually the floor of our cuboid, the base of our cuboid, A, B, C, D. That's the surface there, the AC. So here, we don't have this AC, we don't have the GC, but we can find first the GC by using the volume, because we know that the volume is equal to length times width times height, and we have already our volume, we have already our length and the width. The height is missing. So let us first find the height, which is also this one. This one is the height, the GC. So the volume is 495 here. So let us substitute now. Is equal to 20 centimeters times the width is 5.5 times the height GC. So this one is 495. Now 20 times 5.5 is 110 times 8 is 110 eighths. And then solve for eighths. Eighths is equal to 495 over 110. 4.5 centimeters. So our height here is 4.5 centimeters. This one is 4.5 centimeters. Okay, but still we don't have the AG or the AC. And we are going to find the angle here. This one is angle. Let us say that's angle theta, or angle GCA, or angle GAC, I mean. Okay, so let's find the AC. Where's the AC? We have this triangle here. AC, here, and here. So if we are going to draw that one, we have here, down, not the G, down, here. This one is A. We are looking down. This one is our D. And that one is our C. If we are looking down, we can see this triangle here. And this one is 90 degrees here. That one is the 90 here. That point D, that one. C is there on the base, on the floor of our cuboid. That one. Now, this one, this DC is 5.5. Don't be confused with the 4.5. It's different. This one is the height. This one is the width. And this one is 20 centimeters. So can we find the AC? Because we need the AC for the AC here. So we can solve for the angle. So we can use Pythagorean theorem. So let's have the AC. This one is the hypotenuse. So we have AC squared is equal to 20 squared plus the 5.5 squared. And then we have AC squared is equal to 20 times 20 is 400 plus we have 5 times 6 is 30 and then 25, that is square of a number or a number ending in 5. And then we add AC squared is equal to 400 plus 30.25 is 430.25. We take the square root of that one, square root of 430.25, and AC here, the length of AC is equal to 20.74 cm. Therefore, this AC is 20.74. The thing here is the 20.74. Okay, so this one is 20.74. This one is 20.74, the base, and then the height is 4.5. Can we get this angle here? Yes. What is this side from here? This H, it's the opposite. Because this one is right angle. And this one is the adjacent. So what is opposite over adjacent? That is tangent. So we have tangent theta here. Okay, that's the angle or AG. Okay, tangent theta is equal to the opposite, which is 4.5 centimeters, of course, and then over 20.74, and then theta is equal to arc tangent, this one, and we have the value of that one. If you divide this one by 20.74, we have 0.21697.2, and then theta shift tangent, and then this one will give us 12.2 degrees. That's the angle of line AG with the base of our cuboid ABCD. That's the base. Number 20, we have the curve y equals x squared minus 2x plus 1 is drawn on the grid. A line is drawn on the same grid. The points of intersection of the line and the curve are used to solve the equation x squared minus 7x plus 5 is equal to 0. Now this graph, because this one is quadratic, this one is a parabola, and that one is a parabola also, but this form is the slope-intercept form, where m is the slope and c is the y-intercept. So here, class, we are going to solve for x. squared here and substitute the value of x squared to x squared here to form our linear equation. So let us solve the x squared here. So x squared, and to write again, minus 7x plus 5 is equal to 0. To solve for x squared, we just transpose minus 7x plus 5 to the right. So we have x squared is equal to positive 7x minus 5. And this 7x minus 5 is the one that we are going to substitute here. And then we have that y. So y here, we are going to replace now the x squared with this one. So we have 7x minus 5 minus 2x minus 2x, and then the one there plus 1. Then we combine like terms. So you have 7x minus 2x is 5x, and then minus 5 plus 1 is minus 4. So this is the equation of our line in the form of slope intercept form. Here 5 is the slope and negative 4 is the y-intercept. Number 21, expand and simplify x plus 3 times x minus 5 times 3x minus 1. So first, we do this x plus 3 times x minus 5. We can do it vertical, in vertical form, or by FOIL. So let's do that by FOIL. So that one, x plus 3 times x minus 5 here. Okay, we have FOIL. X times x is x squared. And then after this one, we have this one, or the outer. This one is the inner. Positive 3 times x is positive 3x. Now let's have the outer. Negative 5 times x is negative 5x. And we have the last times the last. Positive times negative is negative 3 times 5 is 15. Then afterwards, we multiply this, or we'll just combine first. So, combine like terms. So, we have here x squared, 3x minus 5x is minus 2x, and then minus 15. That's our answer there. Now, we multiply this by 3x minus 1. So, let's do it in vertical form. 3x minus 1. Here. First, this one. 3x times x squared is 3x cubed. 1 plus 2 is 3. Positive times negative is negative. 3x times 2x is 6x squared. And then positive times negative is negative. 3x times 15 is 45x. Now the second one, negative 1. Negative 1 times x squared is negative x squared. Negative times negative is positive here. 1 times 2x is 2x. Negative times negative is positive. 1 times 15 is 15. Then we are going to add this one plus. So we have 3x cubed. Same sign, we add 6 plus 1, 7. X squared. Unlike signs, we subtract 45 minus 2 is negative 43x. Then copy the plus 15. And this one is already in its simplified form because we don't have any more like terms here. Number 22, find the area of a regular hexagon with side 7.4 centimeters. So we have a hexagon. So how many sides do we have in a hexagon? We have 6 sides and we have 6 central angles also. So here we have our hexagon. It's regular. So 1, 2, 3, 4, 5, and 6. So we have 6 sides. So we have 6 angles also. 1, 2, 3, 4, 5, and 6. So let us find the measure of one angle only. So how do we do that? Because we know that at a point the measure is 360 degrees. So we have 360 degrees. We will just divide it by 6 because we have 6 angles here. Divided by 6. So we'll have 60 degrees. Okay. So let us draw one triangle here. Okay. This is 7.4 centimeters. That's the length of the side of our hexagon. Now we have this one 60 degrees. And these two sides here, they are equal. Because they are equal, then these two angles here are equal. So what is the measure of this base angles here? That is 180 degrees, because there's a total of these 3 angles here, minus the 60 is 120 degrees. Then we split it into 2 or divide it into 2. So 120 divided by 2 is 60 degrees here and 60 degrees here. So what kind of triangle is this? This is an equiangular or equilateral triangle. Therefore, if this side is, so we have another mark there. If this side is 7.4 centimeters, what can we say about the two sides? They are also both 7.4 centimeters. Okay, cm. Okay. Now, let us find the area. Because we are going to find the total area, let's have the area of one triangle first. The area of a triangle is 1/2 base times height, right? Area of a triangle, this triangle is equal to 1/2 base 7.4 times the height. But the problem here is we don't have the height. So we need to find first the height. So what we do is we divide our triangle into 2 so that this one is 60. So this one is 30 degrees. And then we divide also the 7.4 here. So 74, we have 3.7 centimeters. So here we will use the 30 degrees, 3.7, and we solve for 8. After solving for 8, we can solve the area of one triangle, and then we multiply it by 6, we get the total area. So here, if you want to use this 8, 1/2 be 8, then we have tangent 30 degrees is equal to the opposite. 3.7 divided by 8 is solve for 8. But there is another way using the extended area for angle and sides. So we have this formula, which is 1/2 the 2 angles times sine of the sandwich angle, or the angle in between side A and side B. So here, class, the A is this one, the B is the other side, and the C is this angle, the angle which is in between 7.4 and 7.4. So here, the area now of this triangle is area is equal to 1/2 times 7.4 times 7.4, and then sine of 60 degrees. We will not divide it anymore because that one is our formula, not that one. So we have area of one triangle is equal to 1/2 times, okay, this one is 7.4, the same, 7.4 times 7.4. Now let us get the sine 60. So sine 60 is 0.866. And our area here for one triangle only, multiply 7.4 times 7.4 times 0.866 equals divided by 2. And we have area of one triangle is 23.7 centimeter squared. Okay, that is not yet the total area because we have 6 here. So the total area of our hexagon, total area, is, we just multiply this by 6 because we have 6 areas. So 6 times 23.7. So the total area is 142.2 cm squared.